Okay, so in this video, we're going to get a lot of practice simplifying complex rational expressions. Okay, now in the two examples on this slide, we have a single fraction divided by a single fraction in both cases. So you can, in either one of these cases, multiply by the reciprocal of the divisor. I'm going to look at it both of these both ways, but I'm going to concentrate on that multiplication by one just because I want us to get good at that skill. So in this first example, we have 4p plus 1 divided by p minus 2 divided by p. Okay, so if we look at the little denominator in the numerator and the little denominator in the denominator, it's p, right? So if we multiply numerator and denominator by p, what do we have? P cancels here and it cancels down here, right? So we end up with 4p plus 1 divided by p minus 2. Okay, and I would say that p can't be 0, right? Because p was in the denominator in the original expression, so make sure you state that restriction. The numerator doesn't factor at all, nor does the denominator, so we're in fully simplified form here. Okay, so that was so easy, right? Just multiplying numerator and denominator by p. Okay, so alternatively, you could have had 4p plus 1 over p times the reciprocal of the divisor, p over p minus 2, and then these p's would cancel, and then you'd be left with 4p plus 1 divided by p minus 2, right? So I just want to show you get the same thing either way, but in this case, you know, multiplying numerator and denominator by p is very easy. Okay. So now let's look at this next example of z over z minus 2 squared, quantity squared, divided by 2z divided by z squared minus 4. Okay, now one of the things that I notice, you can just multiply by the reciprocal here, but I want to just notice some things. So I've got z over z minus 2 quantity squared divided by 2z divided by z squared minus 4, which is z plus 2 times z minus 2. So if we look at our little denominators, quote unquote, right? I'm going to circle them here. So we have z minus 2 quantity squared, z plus 2 times z minus 2, right? So the LCD here between those two is going to be z minus 2 quantity squared times z plus 2, right? So we have z minus 2 and z plus 2 as factors, but it appears twice in that denominator in the big numerator, right? So we have to include it twice in the LCD. Okay, so let me get rid of those little circles. I'm going to multiply the big numerator and the big denominator here by z minus 2 quantity squared times z plus 2. Okay, so in the numerator, z minus 2 quantity squared goes away, right? And we're left with z times z plus 2. And then the denominator, z minus 2 goes away. One of them goes away here. And z plus 2 goes away. Okay, so in that in the 2z times what's left over, z minus 2, right? One of them from that numerator. Okay, so now the z's cancel there, right? So we have z plus 2 over 2 times z minus 2. Also, think about the restrictions here. So I'm thinking about all the things that were in the denominator of the original, right? So z can't be negative 2, right? The z plus 2 completely canceled out, right, when we multiplied by the LCD. Also, we canceled out a factor of z, so z can't be 0. But those are the only other domain restrictions that we need to be concerned with. So if you have just a single fraction divided by a single fraction, you can also multiply by the reciprocal, right? Just like we did in this other example. So alternatively, we could say z over z minus 2 quantity squared times z squared minus 4 all over 2z, right? And then I should have factored that while I was at it. Z over z minus 2, quantity squared, times z plus 2 times z minus 2, all over 2z. Okay, so we see the z's cancel, one of the z minus 2's cancel, right? And we end up with z plus 2 over 2 times z minus 2, right? And that's the same thing we got up above, right? When you have a fraction divided by a fraction, sometimes it's easier to just multiply by the reciprocal. Sometimes it's easier to multiply by that factor of 1. Whatever you see to do is fine, all right? But be careful with this method of multiplying by the reciprocal of the divisor, because the divisor has to be just a single fraction. If you're adding and subtracting fractions in the denominator, this method doesn't work without a little work first. Okay, great.